Hi everyone, so we're going to continue here with our Jovian planets. So again, some numbers that I want you to be familiar with is our average distance here. Oops. Average distance from the sun. Right here, 1.43 times 10 to the 9th kilometers. So in numbers, we can see that here. So we can see how large and our distances as they move further and further away. Another thing that we want to look at here is our orbital period of 29.4 years. And then taking again a look at our composition of our atmosphere here and our average temperatures. So we can see a lot of hydrogen, helium, some methane, ammonia, and some water vapor. So Saturn is very similar to Jupiter with its bands and belts that we talked about with Jupiter, except we have a very smooth look here, not as much swirls and contrast between those bands. We also see very little swirling structure on these clouds of Jupiter, so we really don't see that huge cloud swirling idea here like we see with our big great red spot on Jupiter. Here you do see some storms, but again, much less of a swirling look, which makes these storms really easily identifiable on Saturn. So looking at some of these interiors between Jupiter and Saturn, they are very similar in material, though our core here, as we can see, we have a lot less liquid hydrogen than we do on Jupiter. So we can see that difference here with our core. So Saturn's rings is a very important and identifiable feature with Saturn, though during our rotation that we see, there are some points that we see these rings full on, and there are points where we don't see the rings at all. So we can see this is pictures of Saturn in different parts of its orbit here. We can see full-on rings here, where we can see that there are rings with this line that comes across the planet. But again, you can't really see the ring part of the planet on here. So our rings here are very famous, and it actually just is a numerous amount of those thin ringlets that we see here. So there's a very big gap that we can see here. And in that gap, there is even more ringlets. So we have many, many rings on Saturn continuously rather than just a couple large rings here. Ooh, excuse me. So when we look a little bit closer, we see that there are thousands of these ringlets making up the rings of Saturn. So looking at some natural color here, we can see kind of a little bit of all those thin different rings or ringlets along the outside here. So our F ring is actually kept in place by two small satellites or asteroid type things on either side of it. So if we see here, we have Pandora and Prometheus holding this F ring in place. These satellites are called our shepherd satellites too, because they're kind of holding something in place, keeping it where it's supposed to be. So just take a little bit detailed look here at Saturn's F ring. We can see how it is kind of farther out, but being held together by those satellites. We also see some of these dark spots along the rings here. So these are believed to be electrically charged particles that's interacting with Saturn's magnetic field that comes around the planet here. So Saturn has a ton of diverse moons that we're going to talk about a few of them here. So we can see some of the different features on here. We have large craters, we have zones without craters, heavily cratered zones. We kind of have differences in our hemispheres here, where we have one crater that has one hemisphere that has many, and others with different things, like right here with our white wispy streaks on our moons here. So some of the moons here is Enceladus, our icy plumes. We can see some of this interesting color that comes off of this moon too as well. So our biggest moon that we're going to talk about here is Titan. So Titan here has a really thick atmosphere, and we can see some of these clouds that cover around, and it's very, very hazy, kind of similar to a little bit of Venus with those thick clouds that are hard to see through here. So our atmosphere on Titan is 3 times thicker than ours on Earth. And it's composed of nitrogen, methane, and a variety of carbon-hydrogen compounds, which we call hydrocarbons. So looking at some of these hues on Titan, we see some of these images from different spacecrafts. Here we can see we have some smooth terrain, and we can see that we also have some terrain that's very high in elevation here. So we have smooth and rough terrain on the surface of this moon here. So if we look a little bit of our map here, we can see some of these very strange surfaces here. We also see Titan's lakes. So these lakes are actually made of methane and ethane. So these are 2 different hydrocarbons. And you can see our comparison from our Titan lakes to our lakes on Earth with Lake Superior here. So we can see some of these similarities here. Another moon that we're going to talk about is Rhea. And this moon actually has some rings around it as well. So looking at some of our newer observations here, we can see that this moon is actually surrounded by rings like Saturn. So this would be the first ring system that's around a moon rather than a planet. So it was detected large debris disk around this moon, and it's proposed that a halo containing these particles ranging from grains, so very, very small rocks, to boulders. So we're going to shift gears a little bit and do a little bit of a comparison between Uranus and Neptune here. So for Uranus, we're going to take a look at our average distance from the sun again, so 2.87 times 10 to the 9th kilometers. I also want to take a look at our orbital period, which is 81 years. And again, taking a look at our atmospheric composition, a lot of hydrogen, helium, and methane here. When we're looking at Neptune, looking at our average distance from the sun, we can see it's 4.5 times 10 to the 9th kilometers away from Earth. Taking another look at our orbital period, 164 years, which is a huge difference just from Uranus itself. And then taking a look at our composition, again, high in that hydrogen, helium, and methane here. So our Uranus and Neptune comparison, we have very similar sizes here, as you can see, but our Earth on the same scale is significantly smaller than these larger Jovian planets. So a really interesting thing about Uranus's axis is that it's actually rotated completely on its side. So our axis points towards the sun in some ways, creating really drastic seasonal changes on this planet. Taking a look at some interiors here, we have a very similar layer with even similar lengths in each of those layers. So we can see liquid hydrogen and helium, highly compressed water on kind of our mantle layer, if you say, and then a really rocky core here. So magnetic fields of Earth, Jupiter, and Saturn are nearly aligned with our axes, but if we're looking at the comparison with Uranus and Neptune here, we can see that our electronic fields do not match our axes here. So we can see our axis for Uranus here, but our electronic fields are completely almost in an opposite direction. And same here with Neptune. We have our axis here and our electronic fields 47 degrees in the other direction here. So another thing that we've discovered about Uranus are these dark rings that we can see around it. So sometimes in this planet's orbit, we can see this occur, which is called occultation. And during occultation of this star, we can see decrease before and after the planet's disk. That proves that there are rings surrounding those planets. So we can see those differences, as you can see in this graph here, of our ocular range, which shows those rings in between our view of that star in Uranus's rings. So talking about some moons here, so moons of Uranus. So these rings are much darker, and we have fine dust particles between the rings. So the moon Miranda is our Uranus moon. Patchy surface suggests that there are huge chunks of rock and ice that came together back after a huge impact on Uranus. So we can see that moon around here. When we're looking at Neptune's atmosphere, ultraviolet images reveal a band-like structure that is kind of similar to Jupiter and Saturn. So we can see some of these bands here. We also see a great dark spot on Uranus that is surprising to find on the planet, where it was thought the temperatures were too cold to actually sustain any storms like that. So we do see storms that occur on Neptune's atmosphere. So again, like Uranus, Neptune has these dark, thin rings that surround it here. So we can see those a little bit in this image. And Neptune's moon Triton has a retrograde orbit around the planet, suggesting it was captured by Neptune. So unlike the Earth's moon and Uranus's moon, it wasn't produced from a collision. It was captured by the atmosphere in Neptune. We can also see on this moon here that possible frozen water ice lake here. Okay, so that's where we're going to end for this video. Remember, if you have any questions, make sure you reach out and ask. I'll see you soon.